friends. We're going to talk about electrical power and energy today. We're going to do some quick calculations, and hopefully this will be the most practical application of our electricity work that you have. You'll actually be able to take a look at an appliance that you have and evaluate how much power it's drawing and then how much it costs you to run that device. So your parents will be able to say, what, you are costing me $10.30 to run the space heater every morning? So hopefully it will be a useful application of these equations. So let's take a look. All right, electric power, really broadly defined as the rate at which electrical energy is converted into another form of energy. In more simple terms, we are drawing electricity from power companies, right? Most of us probably have Pico, and that electricity is actually converted into something usable for us, like a light bulb or a toaster oven. So we're converting electrical energy into light energy or thermal energy, and we measured in watts. So this should feel really familiar to you, and watts are pretty straightforward. They are defined as the current and the voltage. So we know from studying Ohm's law that current and voltage are inherently linked together, and watts is just those two things. It's like a quantifiable unit that we can determine by looking at the voltage and by looking at the current. Okay, and that's what we say. Okay, there's this many watts in this electrical device. Okay. So it can be converted into mechanical energy like a motor or heat or light, whatever it is. So electrical power, we use the term P, power. That makes sense, right? And that's equal to current times the voltage. So really simply, the next equation you need to have in your head is P equals IV, which means to get the watts of something, you multiply the current times the voltage. Now, if you're really savvy and you're thinking, oh, well, what if I have like a circuit and I have the resistance and the voltage, but not the current? You could use Ohm's law to solve for the current, and then you could multiply the voltage times the current to get the wattage. So yes, you can apply some of your knowledge of Ohm's law into this equation. But it can also be done independently. So watts are equal to the amps times the volts. So on many of your devices, watts are already listed, but some devices just have amps listed. And the way you would figure out the watts is by multiplying the amps times the volts. Now, here's the piece of information you need in your brain. Are you ready? Ready? You're paying attention? Our electrical outlets run on 120 volts. That is what, when we plug things into the wall, 120 volts worth of voltage are coming from. That's like our source of energy, right? Now the current is determined by the device and the resistance and the wires. So here's a device here. And oftentimes, if it's produced for the United States, the amps and the watts are listed on the device. But sometimes it is just the amps listed. So we always know what the voltage is if it's plugged into the wall. It's 120, okay? So let's do a really quick equation. If there is a 60-watt light bulb connected to a 120-volt circuit, how much current would flow through it? Okay, so hopefully you were able to manipulate the equation. And you started with 60 watts, and that is equal to I times 120. You divide 120 from both sides, and you come up with I know you got that answer. Okay, so another one. How much voltage is needed to provide 0.3 amps to a 100-watt light bulb? Let's pause here and work on that equation. All right, so hopefully you wrote out your variables. P equals 100 watts, I equals 0.3 amps, and V we are solving for. And you manipulate the equation, and I came up with 333 volts, which is kind of silly because that's not the voltage we have coming out of our walls. So that's okay, just an example. How to manipulate the equation. All right, here's the important part. Ready? We are going to calculate energy use. Now, I have another video where I walk you through this step by step on paper, but I just want to point out that calculating energy use is as simple as taking your watts and multiplying it by how much you are using it. So I have, let's see, my Alexa. There she is. Okay, so I use Alexa 24 hours a day. I mean, I don't actually use Alexa 24 hours a day, but she's like always listening. So she's plugged in all the time, and I would use 24 hours a day as my time for how often I am using that device. So let's take a look. Power and time can be used to calculate the energy being used. So when your parents say, like, you're wasting energy, you're wasting power because you're leaving your devices plugged in, this is what they're talking about. Energy equals power times time. So if you're wasting energy, you are leaving the power being drawn through your device in for a set amount of time. And typically we measure power in kilowatts when we're talking about energy use, because watts is a pretty small thing to draw upon. So we talk about kilowatts. Your electric bill would be charging you in kilowatt hours. So super simple conversion, 1 kilowatt equals 1,000 watts. Amazing. So power times time is commonly expressed in kilowatt hours. So you're just multiplying watts times hours. Okay, so let's do this equation really quick. Pause here and we'll see if we can do this. All you're doing is multiplying kilowatts times 2. So let's convert 60 watts into kilowatts, and then we are going to multiply by 2. Pause here. Okay, did you do it? Did you do it? Because I did it. I did it on my paper. Look. I did it. You did it too. I know it. All right, you convert 60 watts to kilowatts. You should get 0.06 kilowatts multiplied by 2, and you come up with 0.12. So 0.12 kilowatt hours is how much energy was used during that span of time. Okay. So now to calculate the energy costs, really simple. All you need to do is take your kilowatt hours and multiply it by how much your energy company charges you. So I looked at my bill. Wait, I'm going to go get my bill. One sec. I lied. I couldn't find my bill because I signed up for paperless billing. So I just looked on my computer, and I get charged 12 cents per kilowatt hour. So I can use that to evaluate how much I am using for energy. So if you know the cost of your energy per kilowatt hour, you can calculate your energy cost. So you can get your parents' bill and actually look and see how much your family's being charged per kilowatt hour. Some of you might be a little bit more, some might be a little bit less, depending on your energy efficiency that the company bills you at. And some of you might have some alternative energies like solar panels on your roofs, that kind of thing. So it will be different for all of you. But the national average is 12 cents. So if you don't know yours, you can just use 12 cents. All right, so let's try this one with 8 cents because, you know, it's like a little bit cheaper. If electrical energy, that's your kilowatt hours, costs 8 cents per kilowatt hour, then a 60-watt light bulb can be lit for 24 hours at what cost? Let's pause. Okay, so did you convert the 60 watts to 0.06 kilowatts first? And then you multiply it by 24. So 0.06 times 24 is 1.44 kilowatt hours. And then I get charged 8 cents, so I'm going to do 0.08, so times 0.08, and it costs me 11 cents to run that light bulb for 24 hours. All right. Okay, so last thing before I send you off to your lab, if you don't know the wattage, you can actually look at the amps, because remember, power equals voltage times the amps. You can look at the amps and just determine the wattage from there. So I'm going to use Alexa. Alexa, how many amps do you use?
Here's something I found on reference.com.
No.
Using Ohm's law.
No.
1,500 watts of energy uses 12.5 amps.
That's not what I want. Okay, be quiet. Alexa, how many watts does your device use?
Here's something I found on reference.com. As of 2014, a cell phone typically consumes about 2 to 6 watts of electricity when charging.
No, you're totally useless. Okay, so I can look on the bottom and see that she uses 1.8 amps. And I know she's plugged into the wall, which is 120. So really quickly, let's do 1.8 times 120, and that is 216 watts for Alexa. Okay, so the example I think uses this fan, which is 50.52 amps, 120. What is the wattage of the fan? So same idea as what I just did with Alexa. All right, now you are going to get your own device. You're going to do a sample calculation using my hair rollers. That video is posted on YouTube. And then you're going to do a sample problem using my GameCube. And assuming that I play my GameCube for 5 hours a day, every day during this quarantine, I want you to figure out how much it cost me to play Super Smash Bros. Nonstop. And then you're going to evaluate your own electrical devices, appliances. My suggestion is you don't use anything with a battery pack. So if you use like the switch, you will be confused because the switch will say it has a different set of volts. That's because it has a battery pack. Okay, so we're just like standardly making the volts 120. It's for devices that plug into the wall. If you really want to do the switch, then the switch is actually 39 watts if it's plugged into the wall. So you can figure it out that way. So that's all. That's what we got. All right. Pretty straightforward and simple. And there's going to be an assessment next week on these calculations. So that will be the steam turbine generator, circuits, Ohm's law, current resistance, and voltage, and then energy, wattage, and kilowatt hours, and calculating energy use. And that's it. So, and then we're done with electricity, and then nuclear power, because, you know,